Today I want to show you guys a very cool right triangle. Let's have a look. So if I start with the base, let's say 1 right here. And you can always start with some lengths that you want. And what I'm going to do is, I'm going to multiply the 1 by a certain factor. I don't know what it is, I will just call it x. And I'm going to make that into my second leg like this. So let's say here's x. Now, as I said, I want a right triangle. So I'm just going to connect the dots, connect the ends right here and here. Okay, here's the cool part. What if, for the hypotenuse, I also wanted to multiply x with this right here to here, so I will get x squared. Is this possible? Again, we start with 1 and we multiply by some number, we get to x, right? And then if we multiply by the same number again, which is x squared, and I'm trying to put it here, and we get x squared. Is that possible? Well, let's go ahead and figure that out. Since this is just a right triangle, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. A and b are the sides or the legs, and c is the hypotenuse. So based on a squared plus b squared equals c squared, we get 1 squared plus x squared, and make that c is x squared, and then we square that again. Okay, and then solve it. This is 1 plus x squared equals x to the 4th power. Whoa. We end up with a 4th power equation, but it's actually not bad at all. Because the truth is, we can look at this as a quadratic equation, but in terms of x squared. Let me show you. First, let me bring these two terms to the other side. I'll write this down here first though. X to the 4th minus x squared, and then minus 1 is equal to 0. And then for this right here, I will look at it as x squared, and then minus x squared, and then minus 1. Have a look. Here we have the input x squared, and here we have the same input, right, to the 1st power. This is a quadratic equation in terms of x squared. We can use the quadratic formula. Here, let me write down, let's say t squared, at squared. Because I have x right here already, let me use t plus some number b times t plus c. If this is equal to 0, then the input t is negative b plus or minus square root of b squared minus 4ac all over 2a. Here our input is the x squared. So I will say x squared is equal to, b is negative 1, so we have negative 1 plus or minus square root. B is negative 1, square that, minus 4, a is 1, c is negative 1, all over 2 times 1. And then we see that's 1 plus minus square root. This is 1 plus 4, which is 5, and then over 2. Keep in mind though, this right here is just x squared. Now here's the deal. X squared should not be ending with a negative number. If you do 1 minus square root of 5, the result is negative, so we have to get rid of that. X squared is 1 plus square root of 5 over 2. In fact, that's what we call the golden ratio. And of course, right here, we can take the square roots both sides, technically put a plus or minus, but x is the length of a triangle, so I don't want the negative either. Cancel this. Finally, in order for this to work, x is the square root of the golden ratio. I will write it down like this. Yep. I think this is really, really cool. And here's a question for you guys though. What if today I'm going to kind of just relabel the triangle a little bit? So for the blue one, what if now I'm just going to do like this instead? What if I want the shortest side to be x squared, and then the second shortest side is x, and then the hypotenuse is 1? Will that possible? Let me know. I actually haven't solved this yet, so yeah, let me know. Here's the triangle.